Alright guys, so today we're going to do our test review here. So we're going to do some fill-in-the-blank notes, but first of all, I want to make sure that you are listening with headphones, so please, if you are listening, just press the number 2. 2 is the right answer. Okay, so hopefully you got your headphones in. Now first of all guys, I just want to emphasize again that these interactive videos, they are points, alright? I just want to emphasize that. So I can see exactly who's gotten what on these different videos here, right? And getting scores like this is totally fine. I don't expect 100%, although as you can see, it is possible, all right? If I click on any given student, by the way, so hopefully, I don't think Rod will mind me picking on him, right? This is a perfectly good score for this video, all right? 9 out of 12, perfectly acceptable. It's just that when you do get something wrong, guys, please make sure that you actually think about why you got it wrong, all right? That's kind of the whole point of me creating the trick questions with the multiple choice. So don't just be like, oh, I got it wrong, whatever, and move on. Take a note of it, right? If you got it wrong, there's a reason you got it wrong, and there's a good chance you'll get it wrong again. So just be aware, guys, these are worth points. Again, I will curve it so that even if you get, 75%, I'll curve that up to at least a B, all right? Because I don't expect 100% on these. So anyway, bottom line, take it serious, take notes. When you make a mistake, make sure you make note of that mistake, right? Because there's a reason you made that mistake, and there's a good chance that you'll make that mistake again if you don't make note of it. All right, guys. So for these fill-in-the-blank test review notes, I will give you the option to enter your answer into the Edpuzzle tool as usual, but I'm not going to grade these. All right. So it's more just I want you to pause and think about it and try to answer them. But I'm not going to grade them, right? This section will be free points. So, combining like terms happens with which two operations? So we combine like terms when we are adding and subtracting. Right? Not multiplying, dividing. If we're multiplying and dividing, we're not combining like terms. Alright, to combine like terms, both the what and the what must match. Both the variables and the exponents on those variables, right? All the variables, all the exponents on those variables must match. All right, so for example, x squared plus x squared is 2x squared because they are the same variable with the same exponent, so of course we just combine like terms. 1 plus 1 is 2. Don't mess with the exponent, right, when we're doing addition or subtraction. X plus x squared, however, you can't simplify that anymore, right? You can't combine it or anything else. It just is x plus x squared because these are the same variable, but they don't have the same exponent. Okay, we solve what, which have what signs? What type of things do we solve? We solve equations, which have equal signs. All right, now, in contrast, we simplify what, which do not have equal signs. We simplify expressions. All right, so just don't ever forget, guys, the most important part of anything is what are you doing. So if you're not solving, don't try to solve it. If you're simplifying, right, don't try to solve it. If you are solving, well, then of course solve it. All right, what is the golden rule of equations, guys? The golden rule when solving equations, what you do to one side, do to the other. Alright, so that's that section. Alright, now let's talk about fractions, guys. So, to add and subtract fractions, we need to have a blank blank, a common denominator. To multiply and divide fractions, we do what straight across? We just multiply straight across, but of course with division, we flip the second term first. Alright, so with multiplying and dividing, we multiply straight across. It's easy, but of course division has that extra step where we flip the second term first. Alright, so real quick, guys, 1/2 minus 1/3, so that's when we need to make a common denominator, right, when we're adding and subtracting. Division, we flip it to multiplication, right? And you flip the second term, so it's 5/1 now, and then you multiply straight across. Easy. 2 times 5 is 10, 3 times 1 is 3. All right, so division and multiplication are easy. Just flip with division. Adding and subtracting fractions, that's when you need your common denominator. 3 minus 2 makes 1 over 6. All right, so a lot of people have a lot of trouble this unit with reducing radicals, right? To reduce radicals, or square roots, right, we break it down, factor it, looking for what types of things. With square roots we would be looking for perfect squares. Right? These come out, these perfect squares come out by whatting them? By square rooting them. Right? So all I'm saying is that when you take it out of the radical, you square root it. So, for example, square root of 32. That breaks down 16 times 2, right? Now, 32 breaks down more than just that one way, but this is the way we want to break it down because 16 comes out, becomes a 4, right? When it comes out, you take the square root of it. It's not 16 anymore, it's now 4. We've taken the square root of it, right? So it's gone now, and it's just 4 root 2, right? 4 root 2 is our answer. Now, square root of 100, guys, don't get thrown by this. The square root of a number that is a perfect square is just that number, right? 10 squared is 100, so the square root of 100 is 10. Don't keep the radical, right? A lot of students like to keep the radical on it. No. Once you take the square root of it, it's gone, and in this case, guys, there's nothing left behind, right? Here we have the 2 left behind because only the 16 came out, but not here. All right, next, guys, exponent properties. So, unlike previously, y'all, unlike these two sets of notes, I will be grading this part, all right? So I'm going to ask you, to put what you think is the right answer for each of these properties of exponents, and we're going to go through it. So first one, base times base you add. Second one, base divide base you subtract. Third one, powers of powers you multiply, s times t. Fourth one, b to the negative s. How do we make that happy? We flip it. Next one is the same thing but in reverse. How do we make 1 over b to the negative s happy? We flip it, b to the s. Alright, ab to the s means that all I'm saying here is that each part does get the exponent there, right? Remember, even if it's coefficient, it gets it. Next one, a over b to the s. Again, same as the previous one. Each part gets the exponent, a to the s over b to the s. Anything to the 0 is 1. Alright, how do we change the form? Alright, so that's what I'm going for here is how do we change the form? B to the power goes up, root goes on the bottom, right? That's our rational or fractional form for any radical. Don't forget, guys, most importantly, b to the 1/2, same as square root. Alright, a negative number to an even power turns positive, and a negative number to an odd power stays negative. Alright? And then finally, guys, is this tricky last topic, alright? Solving rational exponent equations. That was the notes that we took on Friday that were, tricky videos. So try to remember how this works, y'all. What type of roots always need a what? So even roots always need a plus minus. Alright, for example, x squared equals 16. I take the square root of both sides, an even root, and x equals plus minus 4, right? Why? Because negative 4 times negative 4 is also 16. So we need that plus minus. Alright, what type of roots of what type of numbers need a what? So I know that's a lot there. So even roots of negative numbers need an I, right? So even roots always need a plus minus. Even roots of negative numbers need I. So for example, same thing as above, right? But this time I have the plus or minus still, and I also have the I. On the other hand, what type of roots are what? Odd roots are easy because we keep the sign, all right? So if it's, some people say that it always turns at negative. No. Odd roots of negative numbers keep the sign. So if it was negative, it stays negative, but if it was positive, it stays positive. And no, we don't ever need an I with odd roots, right? You only need the I with the even roots. So x cubed equals negative 8, stays negative, right? You take the cube root of both sides, cube root of both sides to get rid of that third power. Cube root and cube cancel, cube root of negative 8 is negative 2. Alright guys, now at the end of Friday's video, I showed you that there were 6 problems that were kind of homework, but I know most people didn't get to it. So I am going to ask you to do them right now. I would recommend just doing one at a time and then seeing me do it. I will ask you to enter your answer because I do want to take it seriously. Alright, so go ahead and put your answer down for number 1, and then I'm going to go through it. Okay, so guys, our base is isolated already on this problem. Here, on the next one, guys, look, our base is not isolated. It has that 2 hanging out, but here it is. So once your base is isolated, guys, because that's the first step, isolate the base, now we can take the reciprocal exponent. What you do to one side, do to the other, all right? Oh, and I did not do the reciprocal there, did I? I did the same thing. So 3 over 1. 3 over 1. All right, so 1/3 and 3 over 1 cancel each other out, right? Those cancel each other out, and I have x equals 2 to the 3rd. Nothing fancy about this, guys. It's just an odd power, nothing fancy to it. 2 to the 3rd is 8. All right, don't need plus, minus, or I or anything, because all we did was a third power, not a root, all right? Just a third power. So x equals 8, final answer. All right, go ahead and put down your answer for number 2. So this time I can't do the 1/5 yet. I can't do the reciprocal power yet. I got to get rid of that 2. So I divide both sides by 2. All right, cancel. X to the 5th equals negative 64 divided by 2 is negative 32. Now I can do the 1/5 to each side, or the 5th root, right? Same thing as 1/5, y'all. 5th root, same as 1/5. All right, 5th root and 5th cancel. X equals negative 32 to the 1/5, right? Same as 5th root. Now, the 5th root of 32 is 2, all right? Because 2 to the 5th is 32. You can also type that in the calculator, right? 32 to the 1/5, it'll tell you it's 2. But the problem is the calculator can't tell you about the I, right? It can tell you that 32 to the 1/5 is 2, but it can't tell you about what to do with this negative, or if you need an I or a plus, minus, or any of that, all right? So here's the deal. It's an odd root, right? Odd root. Odd roots are easy. If it was negative, it stays negative. You don't need an I with an odd root. All right, that's it. That's the final answer. All right, guys, the next one I'm not going to ask you to put your answer down because it's a bit tricky. It's a bit harder than anything I would ask on the test for the following reason, all right? Because there's one thing that I haven't exactly gone over. Now, first of all, the base is already isolated, right? Because x minus 1 is the base, right? You don't plus 1 yet because first you have to get rid of that 4th power. How do I get rid of a 4th power? With a 1/4 exponent, right? Or 1/4 root. What you do to one side, do to everything on the other, right? Notice you have to add parentheses because we do 1/4 to everything. So we need the parentheses to show everything gets the 1/4. All right, so these cancel, and I bring down x minus 1. Negative 16 to the 1/4, right? This is hard because it's an even root. Even roots are the hard ones. First of all, even roots of negatives become I. Even roots always need plus, minus, no matter what. So the negative becomes the I. The plus or minus is automatic. And then finally, what is the 4th root of 16? Now the calculator can do that part, all right? Or you can use your chart. 16 to the 1/4, or the 4th root of 16, is 2, because 2 to the 4th is 16. All right, check it in your calculator. So that's kind of tricky here, because we have one last step to isolate x. We have to plus 1 to both sides. Cancel. X equals plus or minus 2i plus 1. Now this is the part that I hadn't gone over. These do not combine, guys. It's called a complex number because it has 2 parts to it that do not combine, all right? It would also be written as 1 plus or minus 2i more normally, right? Same thing. But either way, guys, it does not, these two terms do not combine. We just write them both. All right, so I wasn't expecting you to get that one. That one was kind of tricky because we do end up with those two parts there. All right, next one, however, it is hard, but you can do it. All right, we do know everything we need to know to do this problem. So the base is isolated. First thing we do, take the reciprocal. All right, the reciprocal of -2 is -1/2. All right, you keep the negative and you flip the 2, right? And then it will cancel. -1/2 cancels out, but we can do it to everything on this side. So I'm going to bring down x/3. Again, those cancel out. Two negatives make a positive. Here, how do I, let's make it happy, right? Let's just make it happy first. So I'm going to flip it to 4, keep it as 1/2, right? Now it's happy though, it's not negative. 4 to the 1/2, well, that's this. What does 1/2 mean? That means the square root. So that's x/3 equals the square root of 4, 2. Times each side by 3, and we're done. X equals 6. All right? So that's a hard one, but it is fair game for your test tomorrow. All right, so take a minute and look at it. All right, next one. Is the base isolated? Not quite, because of that negative. So first thing we have to do is get rid of that negative. Divide the negative on both sides, right? You could think of it as dividing by -1 if you want. You don't have to show that step. I usually don't. The point is the two negatives cancel out. The two negatives cancel out. All right? And all we have is 2x to the 3/2 equals +8. Now our base is isolated because we got rid of that negative. So now I'm ready to do 2/3 to both sides. All right? 2/3 cancels out. 2x is set free. All right? And now your calculator can do this, right? You just type in 8 to the 2/3 in that calculator. Or we can do it in our heads by doing the cube root of 8 first, which is 2, and 2 squared is 4. All right? So again, you can type in the calculator, or you can just think cube root of 8 is 2, 2 squared is 4. Divide both sides by 2, and we're done. That's the final answer. All right? Oh, but we should check one thing real quick, guys. What type of root did we take here? An odd root. So, guys, that means we're good to go, right? Because it's an odd root, we're good to go. Odd roots are easy. Nothing to worry about. Oh, but look at me. I did make a mistake up here, right? What was the mistake I made? I make mistakes too sometimes. Even roots, y'all. Even roots need what automatic? Plus or minus. All right, I forget that too sometimes. But plus or minus is our final answer there. Plus or minus 6. All right, number 6, y'all. First thing to do. All right, guys, so I apologize. I had two mistakes on how I had written number 6. The 3 and the 4 need to be switched from how I had it written, and it needs to be 1/343, not 1/243. So obviously I won't count this one against you. But anyway, let's go ahead and do this one together here. So first thing to do is to rewrite this guy in the correct form. So x to the 3/4. Now I am ready to take the reciprocal exponent, since the base is isolated, of both sides. So that side cancels each other out, and I have x equals, type this in the calculator, alright? Do this one in the calculator. So 1 divided by 343 to the 4/3. Boom. Math, enter, enter. All right, it's ugly, but at least it's not super ugly. All right, 1/2401. So x is equal to 1/2401. All right, pretty ugly answer for sure, but at least it's not some super ugly decimal. All right. Now, last thing I want to mention, guys, this was an odd root, right? This was an odd root that we took. So do I need anything? No. No I, no plus minus. Odd roots are easy. All right? Change the